What do we have here?
Temperature's critical.
Take them to ER number 2.
Troubleshooting engines is like treating patients with medical emergencies.
Sir, do you have your warranty card?
No, they're not on me.
Leak down's in the red.
I just hit a rut.
Like a doctor, service technicians must have an understanding of how complex systems work in order to diagnose the source of the problem.
Welcome to the 1998 Technical Update Seminar Program. Last year, you asked for information on troubleshooting and emissions more than any other topics. So this year, we've made troubleshooting and emission-compliant engines our main features. Here's an overview of our program. We'll start out with Technically Speaking and introduce several new engines.
In Service Tools, we'll highlight new service items that will help you speed up maintenance and repairs.
InTek V-Twin, a closer look, will give you an inside view of the new InTek V-Twin engine.
In the emissions section, we'll discuss EPA emissions requirements and how it will affect you, the technician, and authorized dealer.
In troubleshooting, we'll explore several proven techniques for pinpointing engine problems.
Service Department will identify common repairs and how to fix them quickly.
And finally, new engine features will showcase the latest in engine technology.
If you'd like to go back and take a look at a particular section, use the running clock at the corner of the screen. Major topics have time references on the video cover, or you can jot down the exact time of the section and review it later.
As you watch this program, keep your Technical Update Seminar notebook handy so you can follow along. It covers these topics in much greater detail.
Briggs & Stratton welcomes a new member into the InTek engine family, the InTek V-Twin. This 20 horsepower engine is exclusively designed for riding mowers and tractors, offering performance and value. Later in our program, we will take a more detailed look at its features and ease of service. Briggs & Stratton proudly introduces 2 new single-cylinder Vanguard engines. The new 6 horsepower Vanguard replaces the previous 5.5 horsepower model, and the larger displacement 7.5 horsepower engine completes the lineup. These engines are a natural progression in the Vanguard engine family and round out the product line. Vanguard 3-cylinder water-cooled engines have also been introduced into our service network. 2 new models are available in both a gas and diesel configuration with identical external dimensions.
I hear a lot of sputtering and hesitation.
I think we have a very sick patient here.
As you flip through the 1998 Service Tools catalog, you will notice many new tools to help you perform your service work more efficiently. Here is a sampling of the new tools available at your Briggs & Stratton supplier. This dial indicator is a critical service tool for Vanguard 3-cylinder liquid-cooled diesel engines. It reestablishes pump timing when the pump is removed. Another important service tool for this Vanguard engine is a compression test adapter. Since compression tests are one of the most common troubleshooting procedures used on diesel engines, you will definitely want to have one of these adapters available. Here is a New Way valve seat cutter kit for reconditioning 30-degree and 45-degree angle valve seats on the new Vanguard 3-cylinder liquid-cooled engines. Improper use of a 19447 C-ring removal tool may cause damage to the drive pins. The replacement drive pins are easy to install and are available separately. Eventually, even the most durable tools can show signs of wear and tear when used on a daily basis. A replacement strap is now available for the strap wrench introduced in last year's Technical Update Seminar program. 3/8 extension, socket, T30, clamp,
Tearing down an engine is a little like performing exploratory surgery. It gives you a closer look at the inner workings of the engine and its component design. The new InTek V-Twin engine is a high-performance, low-emissions engine exclusively designed for riding mowers and tractors. It shares many design features with the Vanguard V-Twin. The emissions regulations played a major role in the development of this engine. Now let's take a closer look at some of the unique engine components with a critical eye of a technician. The vertical shaft engine design features a top-loading reverse flow air cleaner to make servicing quick and convenient. The air cleaner uses a pleated paper cartridge with the largest capacity of any air cleaner we offer. An integral gasket for the intake air is molded right into the cartridge. The blower housing is made from a corrosion-resistant, glass-filled nylon material that is impact-resistant. The air cleaner base is an integral part of the blower housing. You don't have to remove the screws when servicing this assembly. Simply back the screws off slightly around the perimeter of the housing. A new composite ring gear decreases load stress on the gear teeth by about 50% compared to previous designs. A special relief is molded into the ring gear at the rivet points to prevent the gear from being forced away from the flywheel body. This new generation congruent carburetor is specifically designed to increase efficiency and reduce emissions. It is fully non-adjustable and is designed specifically for the InTek V-Twin engine. The governor control bracket and lever functions use a proven and reliable design very similar to the Vanguard V-Twin. The bucket-style rocker arms utilize fulcrum block supports, which allows the valve train to maintain its precise rocker arm geometry. This new design translates into longer valve service life. The reed-style breather maintains crankcase vacuum. This new design allows you to easily remove the collector from the breather cavity for quick cleaning or replacement. This integral oil pump delivers oil using a full pressure rotor-style design. The pump is driven from the end of the camshaft and can be accessed without dismantling the engine. The InTek V-Twin engine includes a standard full-flow oil filter. The oil filter mounting is integral to the sump.
Doctor, she's having trouble breathing again.
Maybe a little oxygen.
No single issue has affected the outdoor power equipment market as much as emissions regulations. After September 1st, 1997, all Briggs & Stratton engines produced for the U.S. market are certified to meet EPA emissions specifications. This does not include engines designed for racing, manufacturers' test engines, or military engines. The purpose of emission regulations is to reduce the number of pollutants released into the environment, such as carbon monoxide, hydrocarbons, and oxides of nitrogen. These pollutants are released primarily due to incomplete combustion. To improve this combustion process, we've added more oxygen to the air-fuel mixture or reduced the amount of fuel introduced into the combustion chamber. To accomplish this emission reduction, we've made design changes to most carburetors and combustion chambers. We strongly recommend that you review the repair manual when servicing EPA-certified engines. Repair and adjustment procedures relating to the fuel and governing systems are most likely to be affected. The California Air Resources Board, or CARB, first addressed environmental concerns based on emissions of internal combustion engines. Briggs & Stratton engines sold in California since August 1st, 1995, have been CARB certified. The letter A included in the trim number identifies these engines. EPA certified engines are identified by the letter E included in the trim number. With the advent of national standards, the CARB identifier has become obsolete. Although engine manufacturers shoulder the responsibility of producing the emission engines, servicing dealers and consumers must also meet certain legal requirements. On page 18 of your notebook, you will see this service bulletin. Review this bulletin carefully because it identifies your responsibilities as a service technician. Page 19 is our warranty statement for emissions certified engines. Here are some important points to remember. The emissions components warranty is for 2 full years from the date of purchase, and the warranty is transferable to subsequent purchasers. take a moment to review the warranted parts which are listed in this document. Emission regulations is very serious business. Altering, tampering, or defeating emission controls carries penalties of up to $25,000 for each violation. Each day the violation continues is considered a separate offense. The EPA requires the servicing dealer to complete emission component warranty repairs on emission-certified engines in 30 days or less. This statement infers that the consumer may take some degree of legal action against the violator. The Briggs & Stratton Emission Regulation Guide takes a more detailed look at EPA and CARB regulations. This guide will be updated regularly. It is your responsibility to understand and carefully follow all emissions regulations. Just how long has this engine been smoking?
About 2 months.
Any other symptoms?
Vibrating, uncontrolled shaking.
Let's order up a Chem 7, a CBC, and let's try out that new leak down tester.
Unfortunately, there is no magical cure for your engine's health problems. Like a doctor, it is your job to gather as much information as possible and to perform tests in order to find the real source of the problem. There is no substitute for knowledge and experience when repairing engines and equipment systems. When troubleshooting, keep an open mind and limit interruptions and outside influences. Change only one item at a time so you can pinpoint the problem more easily. The most common troubleshooting techniques include quick check, easy likely, and systems approach. The most underrated type of troubleshooting is the quick check. This method is the least exploited and most profitable of all methods when used to its fullest potential. When using the quick check method, give the equipment the once-over when it's brought in for repair. This should be done with the customer present or by the technician when it's time to begin work on the unit.
So, what do we got here?
Yeah, it won't start.
Let's take a quick look.
All right. Yeah, it did that to me too.
Well, I can understand why it won't start. The engine's seized. When's the last time you checked your oil?
Oh, you mean it kind of works like my car?
Within seconds, the experienced technician can retrieve information related to the specific engine systems affected, customers' maintenance habits, equipment history, and detailed data that preceded the failure as well as followed it. These initial steps can also help you establish a sense of trust between you and your customers and leave them with the confidence that they did the right thing by bringing the piece of equipment to you. Armed with this preliminary information, technicians will be well on the way to the actual repair or the next step in the troubleshooting process. Easy likely is probably the most common type of troubleshooting method used by the full-time air-cooled engine repair technician. Its effectiveness is directly related to the experience and knowledge the technician has with the particular situation or equipment. With this technique, the technician determines the most likely causes of the problem and those which are the easiest to repair. The framework of the easy likely troubleshooting method looks like this: easy likely, easy unlikely, difficult likely, and difficult unlikely. This system has some built-in pitfalls. The technician must be comfortable that the knowledge used to make the decisions is accurate. You must also recognize that an engine can exhibit a performance problem that may have more than one potential cause. The smart technician, practicing the easy likely method, will normally develop or use existing testing procedures to verify results. But what happens if this procedure does not produce the desired result? If the quick check and easy likely methods don't provide the answer to the problem, use the systems approach. It is by far the most accurate and predictable method to apply to the problem. This method is modeled after the scientific method used by researchers and scientists. It can be a bit more time-consuming, but will usually produce excellent results. The technician divides the engine into basic systems, such as ignition, fuel, and compression. Each system is analyzed starting with the easiest, the system that involves the least amount of effort or disassembly to troubleshoot. This will usually be the ignition system first, followed by the compression system, and finally the fuel system. The same troubleshooting processes apply to emission-certified engines and non-certified engines alike. The certified engine operates using the same principles that all four-cycle engines do. The key to successful troubleshooting is understanding these principles in depth. For example, a customer has replaced his old log splitter engine with a 133412 with an E1 trim number. He complains that the engine won't stay running. What do? Let's troubleshoot using the easy likely method. The easy likely cause of the problem might be the fact that it's a normally operating emission engine. The easy unlikely cause of the problem might be a kinked fuel line. The difficult likely cause could be an obstruction in the fuel system. The difficult unlikely cause might be a burned exhaust valve. You know this is an emission-certified engine by the E1 designation in the trim number. The carburetor is calibrated to reduce the amount of fuel entering the combustion chamber and/or increase the air available for the combustion process. On a cold startup, it may be necessary to feather the choke or repeatedly prime the engine until it can support combustion on its own. This is completely normal and may be necessary for up to several minutes, particularly in cold weather. This makes perfect sense if you understand the combustion process. The fuel-air mixture is compressed to 1/6 of its original size for two reasons: to increase the engine's power potential and to create heat to assist in vaporizing the atomized mix. The engine will run a bit inefficiently until it reaches operating temperature. That's why the engine must be at operating temperature before attempting any carburetor adjustments. An engine requires a richer fuel-air mixture on startup because not enough heat is available to completely vaporize the atomized fuel and air. If you'd like to learn more about troubleshooting, refer to page 24 in your notebook. It lists helpful reference material and videos available to you.
We're losing him.
Paddles, 250.
Charging. Ready?
Clear.
In the service department, we will highlight common repairs that you may encounter. This section begins on page 26 of your notebook. Let's start with installation instructions for large Walbro carburetors. On engines with a choke-o-matic or remote controlled choke, check the linkage hole location and choke shaft material carefully. The technical update notebook gives you the details needed to make this a simple and successful repair. The next service item is an exhaust muffler support bracket. The purpose of this bracket is to increase muffler durability on high vibration applications. Vanguard V-Twin storm engines use the Performance Control electronic governor to provide more responsive governing than the mechanical systems. This electronic governor cannot be retrofitted to mechanical governor engines. Page 28 of your notebook has service instructions for performing a running check and static check of this system. Here's an easy way to prevent your fuel pump vacuum line from freezing on vertical crankshaft opposed twins. Insulate the pulse line with heat shield tubing using the instructions in your notebook. The Model 9 and 10 vertical shaft engines will use a new brake assembly for 1998. Retrofitting an old brake band on a new cylinder is a simple process. Refer to page 30 of your notebook. We changed the governor control system on these engine models from a single governor spring system to a two-spring system. When both springs are used, make sure you follow the adjustment procedure in your notebook. Starter drive gear problems can be easily repaired using the C-ring removal tool that we introduced in last year's technical update seminar. Although commonly used to insert a small screwdriver during the pre-tool era, the notch in the spring retainer is not designed to be used with a 19436 toolkit. The pins in the tool should not be lined up with this notch during the removal process. Using the notch to guide the pins into the C-ring opening will damage the tool. When performing warranty repairs, servicing dealers often have questions on how we process warranty claims. Page 33 of your notebook addresses some of the most frequently asked questions. If you have any additional questions about warranty repairs, contact your Briggs & Stratton Central Sales and Service Distributor for assistance.
We're overheating.
What's the oil temp?
266.
Let's cut back on the O2, please.
Got it.
Briggs & Stratton engines incorporate the latest in engine technology. The result is improved performance and simplified servicing. Let's take a closer look at these new engine features. Model 9 and 10 cubic inch engines now use Sousa starters in place of the old rewind starter and clutch system. This proven design provides a reduction in starting effort and is easier to service. We incorporated this composite crossover tube into all Model 9 and 10 cubic inch vertical crankshaft engines. This one-piece design resists component separation and reduces heat transfer. These engines also feature a redesigned brake mechanism. It incorporates the proven puck design used on Quantum Series engines since 1990. Looking for the primer bulb? This attention-getting red collar makes it easier to find on the Pulsa Prime carburetors. An enlarged crank pin, robust connecting rods, and improved piston assembly are some of the 1998 product improvements in quantum power engines. Let's look at several design changes for the Vanguard V-Twin engine. A new cylinder head design enhances engine performance. It incorporates an oil-impregnated fulcrum block and bucket-style rocker arm to improve lubrication and rotation geometry. This eliminates the cross shaft and greatly simplifies the assembly process. This engine also has new cylinder head gaskets. They have been changed from a formed steel style to a graph oil style head gasket. This design change results in a better seal and improved heat transfer between the cylinder and the cylinder head. We enlarged the magneto side bearing from 30 millimeters to 35 millimeters on the Vanguard V-Twin. This change increased lubrication to the magneto and crank pin bearings. An optional automatic choke carburetor is now available on Vanguard 3-cylinder liquid-cooled engines. It is useful for applications that will be started from a remote location. Identifying main jets on the Vanguard 3-cylinder liquid-cooled engine has never been easier. Each carburetor jet has a number stamped in it. By locating this number on the chart, the technician can determine if the correct jet was installed. If you'd like additional support information on the 3-cylinder liquid-cooled engines, order one of the publications listed on page 38 in your notebook.
Well, Doctor, I think it was a success.
I think you did beautiful work, Doctor.
Repairing engines is no different than repairing the human body when it breaks down. It requires knowledge, specialized tools, and refined troubleshooting techniques to diagnose your engine's health problems.
As service technicians, we are much luckier than medical doctors. Our patients are machines. Their lives and deaths are not exactly in our hands.
Today, Briggs & Stratton manufactures the finest engines in its entire history. They deliver power, performance, reduced emissions, and long life. With your commitment to training, we will continue to offer the highest quality engines and customer service in the industry.
Briggs & Stratton has produced many high-quality video programs to meet your educational needs. Briggs & Stratton's Form CE3014 is your guide to selecting an educational video. Many subjects are covered, such as carburation, troubleshooting, electrical systems, failure analysis, and many more. The following is a short sampling of the many videos available. One segment of the following video covers carburetor theory.
A very simple carburetor could consist of nothing more than a gas tank with a fuel shutoff valve leading into a hollow tube attached to an engine. Now, As air passes through the tube at a constant speed, the only way for it to pass through the venturi is to increase in speed. Speed with direction is velocity. As the air velocity increases through the venturi, the pressure decreases, and we end up with a low pressure area within the carburetor's venturi. This principle is actually a common day-to-day occurrence. The only problem we have left is that once the carburetor bowl is empty, the engine will stop running. Fortunately, that can easily be remedied by adding a system that maintains a constant fuel supply to the bowl of the carburetor so that the engine can run as long as the fuel supply lasts. We start by adding a float to the bowl of the carburetor. The float is connected to a needle. As the float moves up and down according to the fuel level in the bowl, the needle opens and closes to either allow more fuel in to bring it back to its proper level or shut off the fuel supply completely.
Advanced carburetor theory takes up where carburetor theory leaves off.
The higher temperature increases bubble production and increases the chance of vapor lock, which can affect engine performance and may stop the engine from running at all. Let's take a closer look at how those bubbles and vapor lock created problems in some adjustable jet carburetors. As the bubbles increased in number and size, occasionally one would lodge itself at the annulus to work under a light load, such as turning a mower deck. As the engine begins to work harder, the fuel level in the tube drops slightly below the fuel level in the bowl. The jet is a limiting device. Only a specific amount of fuel can flow through the orifice in a certain amount of time. When the engine uses more fuel than can be allowed through the jet, the fuel level. However, when the engine moves to top no-load speed or becomes lightly loaded, the pilot jet begins to affect the engine's performance. The size of the pilot jet's orifice provides just the right amount of fuel needed to maintain the proper speed when the engine is lightly loaded. As the fuel and air begin to mix in the pilot jet,
A good understanding of troubleshooting is important to every technician. The process of troubleshooting is stressed in a lesson in critical thinking. In this video, the audience is taken through several scenarios of dealer and customer encounters. The technician will learn the process of troubleshooting in this video.
try spraying water from a pressure washer under the deck of the mower. The mower blades will suck the water in and produce a loading effect that should let you know if you've solved the problem. When there's no snow around to test a snowblower, run the auger in a pool of water. This will load the engine enough to confirm the repair. To test small and medium-sized generators, use the generator to power a large heat gun or blow dryer. The 1500 to 2000 watts should load the generator enough for you to detect any engine anomalies as well as power availability. If you suspect a problem with the charging system of an engine, use a DC shunt to detect the charging rate of the system as well as current drain and starter draw.
A strong understanding of electrical theory is essential for troubleshooting electrical systems. In this video, we will show ignition, charging, and starting.
First is the speed that the magnets are passing the armature. The faster they travel, the higher the induced voltage. Watch the lights on this tractor. As the engine speed increases and the magnets pass the alternator wires more quickly, the lights become brighter due to the increased voltage and current being produced. The last factor affecting electrical performance is the strength of the magnetic field. A magnet having strong lines of flux will cause a higher voltage to be induced than a weaker magnet operating at the same speed. Basic electrical principles: ignition systems, charging systems, and starting systems. You will learn how they work and how to systematically troubleshoot and repair all three systems.
When this video is used with a companion slide set, the technician will gain a thorough understanding of the why of failures.
Under normal conditions and with proper maintenance, not enough abrasives enter the engine to cause premature wear. The primary potential source of abrasive grit is through the air cleaner. This may occur if there's a rip in the air cleaner element, a loose air cleaner, or because the air cleaner's been improperly or infrequently serviced. Tiny particles of dust and other abrasive grit that are normally trapped in the air cleaner continue into the engine. When abrasives enter the carburetor, they accumulate on the choke and throttle plates. As engine speed increases beyond design limits, the connecting rod begins to elongate. During overspeeding conditions, the narrow end of the connecting rod near the wrist pin is the most likely area for breakage. The breakage of the connecting rod typically occurs as the piston changes direction at the top of the stroke.
Remember, this is just a sampling of the many videos available. Our promise to you is that we at Briggs & Stratton always strive to create videos of the highest quality for the service technician. To obtain copies of the videos or brochure, contact your source of supply and order form CE3014.
So the other day, this irate customer comes in complaining about the bad service he got at some other shop. Well, he says he dropped off his mower and they kept it for 2 weeks trying to figure out why it wouldn't start. He gave him some excuses about having a bunch of new guys who didn't know what they were doing yet. Well, he finally gave up on him and brought his mower to me instead. So I told him he came to the right place. My technicians are fully trained. They really know their stuff. We'll fix it quickly and probably charge you less than that other guy.
Briggs & Stratton training schools and seminars give you the edge you need to get the job done, quick and easy. The Briggs & Stratton Advanced Factory Training School is held at our modern 19,000 square foot facility in Milwaukee. New 4.5-day training programs that will put you to the test. Electrical systems, fuel delivery systems, engine technology, repowering, rebuilding, and product knowledge. You be the expert. We'll show you how at Briggs & Stratton's Advanced Factory Training School. At the Advanced Electrical and Fuel Delivery School, you'll learn how to design, build, and test electrical systems used in conjunction with Briggs & Stratton engines. Ignition switch wiring, charging systems, lighting, starting, and interlock systems. You'll receive extensive electrical theory reinforcement. You'll learn to zero in on trouble spots in no time. And you'll find out how to make repairs in a fraction of the time you're probably used to. In addition to a complete rundown on electrical systems, you'll get expert advice on how to work on fuel delivery systems on Briggs & Stratton engines. Theory, troubleshooting. You'll tear down carburetors and learn how to troubleshoot and adjust the 2-barrel carburetor from the Briggs & Stratton 20-horsepower V-Twin engine. Our other 4.5-day advanced training school is called Engine Technology 1. Here, the focus is on engine dynamics. You'll learn to completely overhaul, service, and repair Briggs & Stratton engines. And you'll cover engine repowering, zeroing in on vibration, heat, horsepower, and electrical connections. For each advanced class, we'll arrange 5 nights lodging, provide breakfast and lunch, and the graduation banquet. Everything you need for class, including manuals, tools, equipment, and a few bonuses, will be provided for you. And we'll even get you to class and back to your hotel each day you're with us. Briggs & Stratton Advanced Factory Training School. You'll learn to work on electrical and fuel delivery systems and Briggs & Stratton engines more quickly and efficiently than ever. And that means you'll make more profits too. To qualify for Advanced Factory School, you need to be a graduate of Briggs & Stratton's 4-day authorized field service school, where we take you through 4-cycle theory, warranty, teardown, starters, engine maintenance, specialty tools, parts, and other topics. It's also a great idea to attend Briggs & Stratton's 1-day Vanguard 2 seminar before enrolling in Advanced Factory School, so you're a step ahead of the game when it comes to this unique family of engines. Briggs & Stratton offers a complete array of training opportunities, starting with the annual Technical Update Seminars, Authorized Field Service School, Vanguard 2 Seminar, all the way up to the Advanced Factory Schools, Electrical and Fuel Delivery, and Engine Technology. It's training that saves you time and makes you money, and it prepares the student to test for the status of Master Service Technician. To enroll in Briggs & Stratton's training schools and seminars, call your regional central distributor. For the Advanced Factory Training School, call 800-934-7730. See you there.